Here we have a matrix A, which is given to us by, say, column A1, column A2, column AN. The transpose of a matrix A we're going to call right dt is a matrix whose rows are columns of A. So the way I can try to write AT is going to be, so column A1 becomes row, column A2 becomes row, and so on. So column AN becomes row AN. Example, if I have matrix A which equals to A, B, C, and D, then A transpose is going to be column AC becomes row. So our columns AC and BD becomes columns. So first column becomes first row. So AC, B, D. Another example. 1, 2, 3, 4, 5, 6. So if I have matrix B, which is given to us 1, 2, 3, 4, 5, 6, then B transposed is going to be, so column 1, 3, 5 becomes row, columns 2, 4, 6 becomes row 2, 4, 6. An interesting property, if matrix A is given by its rows, row A1, row A2, row A3, and so on, row AN, and matrix B is given by its column B1, BK. So if you have two matrices, A and B, A is given by its rows, and it has rows A1, A2, A3, and so on, AN, and A is of order n times n. B is a matrix, and it has columns B1 and BK. So AI is a row of A, ith row, BJ here is jth column of B. Notice that AI and BJ, they all have M entries, M vector. So because of that, we can multiply A times B, and we will multiply it, we're going to get, for example, the first position. To get first position, we multiply first row by from A times first column from B. So we're going to get A1 times B1, first row times first column. Second one is going to be first row times second column, and so on. A2 times B1, A2 times B2, was multiplication of vectors, A1 here, A2 times BK, and so on. So last one is going to be AN times B1, AN times B2, and so on, AN times BK. So we get formula for A times B, what would you notice is, if I write now A transposed, rows of A becomes columns. So now I'm going to have columns A1, A2, and if I write B transposed, my columns B1 and BK, I'm switching rows and columns, becomes now rows B1 through BK. Now, order of A transpose is going to be, I'm going to have n columns, and each column will have m entries, so m times n. Order of matrix BT, I have k rows, and each row will have m entries, k times m. So if you look at the order of our matrices, what we can do is we can take B transposed multiplied by A transposed. So we're going to take B1, BK, and we're going to multiply it by A1 n, and we're going to get something similar to what we get here. So we're going to get B1 times A1, next one gonna be B1 times A2, and so on. The last one is gonna be B1 times AN, next one is gonna be B2 times A1, B2 times A2, and so on, B2 times AN, so on. Last one is going to be BK times A1, BK times A2, and BK times AN. So that is going to be B transpose times A transposed. Now if you carefully look at these two matrices, when you see row A1, B1, A1, B2, A1, BK, and you see the column B1, A1, B2, A1, BK, A1. So those are essentially the same thing. So rows in A times B corresponds to columns in B transpose times A transpose. So what that means? It means if I switch rows to columns in this product, I'll get this matrix. So if I want to put that in writing, if I want to put that in writing, that if I switch rows to columns here, by saying I switch in rows to columns, I'm writing I do transposed, and if I do that, I'm going to get B transpose times A transposed. That's an interesting formula, which we will be using at some point down the road.